Today's lesson is going to be on understanding square roots. Understanding square roots. The definition of a square root is any number multiplied by itself to form a product. For example, the number 3. If you take that number and multiply it by itself, you get a product of 9. So 3 is a square root of the number 9. Another example would be, say, 7. That number multiplied by itself gives you a product of 49. So 7 is a square root of 49. It is a number that is multiplied by itself that forms a product. A perfect square, a number that has integers as its square roots. For example, if I were to ask you what number multiplies by itself to give you 25, you would say 5. 5 times 5 gives you 25. So 5 is a square root of 25. Notice the number 5 is an integer, so 25 fits the rule of being a perfect square since its square root is an integer. An example of a non-perfect square would be something like 12. 12 has products of 6 times 2, 3 times 4, 1 times 12. None of these are multiplying by themselves. It's not 6 times 6, it's not 3 times 3, so none of those are square roots. So 12 is not a perfect square. So 1, 4, 9, 16, and so on, these are all your numbers that are perfect squares up to the number 400. Of course, there are more perfect squares past 400, but these are the ones that we will probably be dealing with in our lessons or our homework. So these are good ones to write down in your margin on your page, just to have them for future reference. If you ever wonder, is this number a perfect square? Just check the list. Is it one of these numbers? If so, just say yes. Now, where does this list come from? A perfect square is very, very easily developed. Now, if I ask you in the future if a certain number is a perfect square, or give me an example of a perfect square, here's how you do it. You just start at the number 1. 1 times 1, and you can do that math, gives you 1. What's the next number after 1 when you're counting? 2. So what is 2 times 2? 4. And you just literally count up and multiply each number as you count by itself, and that continues to give you a perfect square. So as you can see, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So as you go forward, 5 times 5, 6 times 6, 7 times 7, and so on. There you go. An important thing to note about all perfect squares is that they have 2 answers. For example, if I were to ask you what is the square root of 9, in other words, I'm asking what number multiplies by itself to give you 9, you would jump to the answer of 3. You would say, of course, 3 times 3 is 9, so 3 must be the square root. That is true, but remember there are 2 integer answers, or solutions rather. The important word here is an integer. Remember, an integer is a whole number and its opposite. So what is the opposite of 3? That's right, negative 3. Well, just think for a second. What is negative 3 times negative 3? Any two negatives multiplied together gives you a positive, and 3 times 3 is 9. So you get the same result. So the square root of 9 has two answers, 3 and negative 3. We denote this by saying plus or minus 3 using this symbol. In the future, you may be asked whether or not a number is a perfect square. If you look at the list of perfect squares up to 400, you may notice a pattern in that last digit. 1, 4, 9, 6, 5, and 0. There are no other last digits besides those numbers. So a really quick way to tell whether or not a number is not a perfect square, you can check these 4 digits. So for example, if I asked you, is 388 a perfect square? You would say no, right off the bat. It ends in an 8. And following the pattern up above, there are no perfect squares that end in the number 8. Same with the number 2, the number 3, and the number 7. That is one quick way of determining a perfect square or not. However, this does not determine whether a number is a perfect square. For example, if a number does end in one of those numbers, 1, 4, 5, 6, 9, or 0, that does not automatically mean it is a perfect square. 20 is not a perfect square. 26 is not a perfect square. 29 is not a perfect square. So just use these numbers to determine whether a number is not a perfect square. It's very, very simple. Is 22 a perfect square? Well, it ends in 2, so it's not. All right. You may have come across this symbol in the past. This is your square root symbol. It is an operation. It is a grouping symbol, and it's asking you the question, what number multiplied to itself gives you the number on the inside? So for example, to the left, the square root of 64. So it's asking you what number times itself gives you 64. You could go back to your list and say, well, there's 64, so the number must be 8. And that is a very good use of that list. 144. What is the square root? Again, you could go back to your list and check that it is just the number 12. And I am forgetting that there are 2 solutions. So we should denote this as the plus or minus 8, or the positive and negative 12. Same with 196. That is the positive or negative 14. If you forget that plus or minus, it is not okay. You need to make sure you remember this, like I just forgot. But make sure you add that on your answers unless it asks you for just the positive answer. There will be times when you don't need the negative answer. For example, if it asks, or if you get like a geometry question, and it asks you, or it tells you that the area inside this square is 144 inches squared. So it's wondering what is a side length of the square. You would just say that it is 12 inches. You wouldn't use the negative 12 inches because there aren't negative measurements. So there are times when you don't need the negative answer, but when you're just giving a simple question that just says the square root of a number, make sure you include the positive or the negative version. Here are a couple examples you may see just to simplify square roots. expressions. Remember, again, square roots are grouping symbols, so they go under the P for the PEMDAS, parentheses. So this is 3 times, and the square root of 25 is 5 plus 4. Then you move on past that to exponents and multiplication, division. This becomes 15 plus 4, and our solution is 19. So that is one simple way of using square roots in our expressions. So make sure you do the square roots before anything else if they are in your problem. Here's another example. The square root of 16/4 plus 1/2. Well, 16/4 can be reduced to a simpler number. 16/4 is really 16 divided by 4, which we should know is just the number 4. So rewriting that fraction as a whole number, if possible, is a very good route to take. And from here, the square root of 4 is 2, plus 1/2. Our solution is 2 and 1/2. There are a couple of rules that we can use to make our lives a little easier when it comes to some of these expressions. The first rule is that when multiplying only, when you're multiplying two square roots, and they don't have to be perfect squares, when multiplying two square roots, you can multiply the numbers on the inside and put it under a single square root symbol. Once you find the product, you can just write the answer. A couple things to note about this is that it needs to be multiplication only. The next example is one that is not a rule, and this does not work. The square root of 3 plus the square root of 12 does not give you the square root of 15. This is something you should not do. Please do not. The reason behind that is if you just took a calculator and figured out what those numbers were, you would see that these results do not equal the square root of 15's result. And you can check that on a calculator on your own time. The last rule is a division quotient. If you have a square root of a fraction like this, 81/4, you can rewrite the square root fraction as the square root of the top divided by the square root of that bottom number as two separate square root problems. Once you do that, this becomes a very, very simple problem. You can take the square root of 81 on its own to give you 9, and the square root of 4 on its own to give you the number 2, giving us the answer of 9/2. This would be a good way to solve problems when you can't simplify that interior fraction to something that's reasonable. 81 does not divide, or 4 does not divide 81. So let's just use those rules in application here. The square root of 18 times the square root of 2. Remember, we can just multiply those and put it under a single square root. That gives us the square root of 36, which we know is the positive or negative 6. One last example, the square root of 16/9. We can rewrite this as the square root of the top divided by the square root of the bottom. And the top square root is 4, and the bottom square root is 3. And there is your solution. And that's your lesson on understanding square roots. Good luck.